Good morning, good afternoon, everyone. Welcome to Introduction to Geotechnical Solutions from Aarsleff. My name's Ashley Carter, Head of Pre-Construction. I'm going to walk you through some of the things we know, trying to impart some knowledge on yourselves. So on to slide 2, a little bit about the contents of the programme today, a little bit about us. Some information on earth retaining solutions, main focus really being on mini bearing piles. We will touch on soil nails and ground anchors, drilling and grouting, some of the other geotechnical disciplines that are out there that we do, and then we'll finish off with some case studies. So moving on to slide 3. So company profile, Aarsleff, if you know the name, you probably understand that we would be known for precast driven piling. That's predominantly what we did for a long time, but actually the business is very well established, based in Denmark in 1947. That's where it originated from. We have a very wide European business base, operating in many different countries, predominantly in Northern Europe. We came into the UK in the late 80s, early 90s, predominantly for servicing the housing market with the precast driven piling. But in the last few years, we've certainly diversified and got a more broader portfolio of geotechnical disciplines within our umbrella, shall we say, of what we can deliver. Now we're seen as a geotechnical contractor rather than just a piling contractor. In our head office in Newark, we've got a full in-house technical estimating, design, pile production and installation capacities. We cover the whole of the UK. Occasionally we'll go off to the Channel Islands, sometimes Iceland, sometimes France, depends where the job is relative to where some of the other operating centres within Aarsleff are based. Currently got about 165 employees in the UK and in excess of 30 different pieces of plant and machinery that we utilise. Moving on to slide 4. So the group, as we've mentioned earlier, was established in 1947. Total employees about 4,900, so quite a few people. Generates around 1.39 billion euros. We operate in 12 different locations, predominantly Northern Europe. We're involved in infrastructure, climate change, energy, and worldwide projects. So very mixed range of markets that we work within. Moving on to slide 5. So the countries that we actually operate in is Denmark, Russia, Norway, Latvia, Iceland, Poland, Greenland, Lithuania, Germany, Sweden, Finland, and obviously here in the UK. So on to the interesting stuff, earth retaining solutions. First one we're going to just touch on is soil nails. Not necessarily something you've come across, but a very useful system for retaining, stabilizing the earth. Generally, sort of 60 to 70 degree face is what we see commonly. You can increase that to 90 degrees, but you would need a hard face on that, which would be something like shotcrete, sprayed concrete. So there's no way you're going to get a soil nail wall to stand up at 100 degrees, sorry. It's generally between 70 and 90. So always a top-down construction. So you work at the top level, do a reduced level, dig, have a sort of terrace piling platform, and then introduce a row of nails, and then incrementally keep reducing the earth down, put another terrace platform in and introduce another row of nails moving down. That's generally the process. There's a geotextile membrane and then a mesh that's placed upon the face, and then head plates and lock nuts on top of the nails. Generally, we see sort of horizontal and vertical spacing 1.2 to 1.4 meter centres, something of that order. Quite a cost-effective solution relative to other retaining systems. You can handle quite significant retained heights. It's really a function of what the prevailing ground conditions are, what we're trying to retain in terms of embedment or length of the nails. The nails themselves are galvanized hollow bar with a sacrificial drill bit on the front end, so you basically drill them in, and then it's cement grout encased. Really good product for reducing the risk of landslides or any other sort of ground movements potential. Good stabilizing solution. Quite flexible in terms of the equipment that can be installed with. Always something to bear in mind is that you can either have a grout flush or an air flush installation. The air flush is probably more preferable. The grout flush tends to create quite a lot of cement-based slurry arisings at on the piling platform. It needs to be managed carefully. Moving on to slide 7. Ground anchors, another earth retention solution. Probably what we would class as top of the shop in terms of cost. You wouldn't specify these unless you really needed them. They're generally quite expensive. Just the components themselves, unit costs can run into multiples of thousands for a single anchor. However, they can handle significant capacity and loads. Generally, it's used on a permanent installation, but it can be used on temporary. However, you need to take a due consideration of the cost on that. Anchors can be pre-stressed or passive. The actual design of them is a fixed length, which is encased in grout material at the lower end of the bore, and then there's a free length that's unbonded to on the ground. Generally, when you're looking at ground anchors, the usual consideration is for quite a long design life criteria, which generally means that the anchors need to be double corrosion protection. And again, that is something that is quite critical to the design and the costing of a project. So it's always a question we ask early on for those. We'll move on to slide 8 now. So drilling and grouting, probably something not many people know too much about, but essentially it's the introduction of cement grade based materials into voided ground or loose ground where there's been mine workings. So slide 8, drilling and grouting, used to prevent the migration of redundant mine workings and other voids. Can be used for infilling redundant sewers, chambers, foundations, to restrict groundwater movement. Constructed with rotary drilling methods, we can use water or air flush. Water flush again tends to make the site quite messy, and due consideration needs to be taken in terms of managing that arising water and the fact that it'll be cement-based slurry. Air flush is the preferable system where possible, but not always acceptable or allowed, shall we say. Depends on if the mine, where the mine workings are, and if it's consented or not. There's different types of grouting processes and techniques. So bulk infill grouting is main one you'll probably come across. They're used to consolidate large areas, such as abandoned mine workings and voids. Compaction grouting is injection grouting, creating columns of grout that are ideal for treating areas under buildings where you want to apply a load. And then permeation grouting, filling cracks and voids within the soils and rock. Then we've got permeation grouting, which fills cracks and voids in soil and rock. Then we've got permeation grouting, which is essentially filling voids and cracks in soils and rocks. So moving on to slide 9. Mini bearing piles. It's called a multiple of things, really. So it could be mini piles, could be restricted access piles, micro piles. It's one and the same, really. For me, restricted access is all about size, height, and weight. One of those would be the driver for specifying a restricted access piling rig. Restricted access for me, again, goes from sort of handheld equipment up to about 20-ton piling rigs, 12, 13 metre mast height. Similar sort of footprint to the size of a estate car, modern estate car. Lots of different equipment out on the market, lots of different capacities and options that the manufacturers have provided to us to do a number of construction methods. So generally offered as a displacement or replacement piling system. It's well suited to soft and water bearing ground. It relates to the size of the equipment. So there's lots of different equipment that we can use, and there's lots of different techniques that we can use. Generally, we see things such as open hole, boring, CFA, SFA. The SFA, sectional flight auger, is basically CFA, but we're just using shorter string, which is a function of the rig size and how much string of auger you can get under the head of the piling rig. Essentially one and the same. So we can do open case auger, rotary percussive, bottom driven steel piling. That's usually the entry point for mini piling. It's cheap, it's efficient, it's quick. It's the way to go, really, where you can. But there's lots of different options in terms of size and capacity of the pile. But again, when you start talking about piling, you should really be understanding what kind of loads the structure's applying to the ground and what you need to be delivered from the pile design. There are limitations in terms of what these smaller rigs can do, the size, the depth, and ultimately what kind of capacity we can get from the piles. So again, it's always good to engage with the specialist supply chain and find out, what can be delivered in the prevailing ground conditions that you've got and what is the most suitable technique for your particular project. Not only for what you want delivering in terms of performance from the pile, but also, relative to if we've got any restrictions or conditions within the planning consent that would preclude, noise or vibration. We can deal with most things. We just really need to understand, what we can do and what is the most appropriate solution for quite a numerous things that we need to consider. So moving on to slide 10. This is probably a good matrix, if you will, for cost profile. Bottom-driven mini piling, that's probably the starting point for most schemes. These can range from a very small Grundamat handheld 100 mil diameter, 150 mil diameter piles, easy to install, cheap, unit costs, widely used for single and two-story domestic extensions. The 150 Grundemats are still favoured by Network Rail, primarily for ease of installation, because it is equipment that's handled by rather than tracked machines. So moving up from there, the bottom driven, that is installation with a piling rig. Again, good choice of pile, get good performance out of that, low unit costs. But there are limitations as to the cross-sectional area that can be installed for those, and ultimately the performance that you can get from those sort of piles. Away from that, you're moving up really to now a CFA or SFA, sectional flight auger pile. Here we've got a lot more options in terms of cross-sectional area. Generally, we would start at 300 diameter, moving up to 350, 450, 600. There are a few rigs out there that can do a bigger cross-sectional area than 600, but they are in very short supply, shall we say, only used and operated by a few companies, and they do tend to be quite expensive. But if it is something that you need, a big pile with a restricted access rig, then people can do it. The augered piles, there's lots of different options in terms of whether we introduce casings or not. That's all subjective to the ground conditions and whether there's a risk of the bore collapsing or whether it's going to stay open and stable. Again, your piling contractor will give you a good understanding of what is an appropriate pile construction in the prevailing ground conditions that you've got in particular projects. Moving up the scale in terms of cost, there's lots of different drilling systems. Odex is probably the one that you will come across more than any other. It's an overburden drilling system. We drill through weak or voided ground, taking a casing down with the drill head, and there's two options with the Odex system. Those can either be a drill extracted, and we introduce some dry pack material, limestone chippings and cement, and sort of pack up the front end of the casing, and then drive that onto a set like you would a bottom-driven mini piling. The other option is to actually form a rock socket out at the bottom of the casing once you're down to sort of bedrock, competent material. These, by the very nature of the system, tend to be rather slender. So if you're looking for quite high capacities, the rock sockets can be significant in length, 3, 4, 5 meters, not uncommon. But the key thing there really is you would only specify, the most appropriate pile type and construction for the prevailing conditions that you've got, the load cases that you need. So, the Odex system is really top of the shop again. You only go there if you absolutely need to. So moving on to slide 11, bit of a sort of overview of different sort of techniques that we would classify as mini piling or restricted access. So screw piles, those can be introduced with restricted equipment. The Grundemat pile, very common, good entry-level pile, but it does have its limitations in terms of capacity and performance. Odex piling, we've just had a little bit of discussion on that before. Good pile, a lot of potential in there in terms of axial capacity, not much in the way of horizontal, just by the limitation of the cross-sectional area. The bottom-driven steel case pile, really good pile. Those range from 150 diameter up to 323. top driven steel, precast timber. If you're driving from the top, you've got a lot more options in terms of what you can handle, sort of size and shape, shall we say. The steel being circular, precast, square, timber, circular or square. There's nothing to stop you driving H sections, I-beams, that sort of thing. Open hole auger, that is just a technique that assumes that the bore that we're going to make with the auger string in the ground means that the hole is going to be open and stable, such that we could extract all the equipment and then introduce concrete from the top without necessarily pumping from the bottom. Sectional flight auger, again, this is sort of the restricted name for CFA type piling. Lots of options there in terms of size, depth. So really a function of the size of rig that we can get in there and the torque value that provides relative to the ground conditions that we've got. Good pile, lots of options. You can use grout rather than ready mixed concrete. Get plenty of reinforcement in there, so there's good capacity range in terms of what those piles can deliver. Very common pile to be installed. Down the hole hammer drilling, DTH, the abbreviation. Very expensive rotary percussive hammer on drill rods, temporary casings. Yes, you can get through a whole range of materials with those, but do tend to be quite expensive as a unit cost. So again, you wouldn't really specify those unless you really needed one. Drilled micropiles, similar in a way to the soil nails, but in the vertical axis. Threaded bar, sacrificial drill head, and then form a grouted collar around those piles. Good piles. Widely used. Moving on from those, it's just really the configuration of what we do with these piles. Do we arrange them as single piles, individual piles, or groups in caps, or do we put them together in close quarters into something what is known as a contiguous wall, or a secant piled wall. The secant being an interlocking pile, one pile cutting into another to essentially provide a watertight system, wall, and the contiguous pile has a spacing in between the piles, not enough to allow too much ingress of materials, but obviously if there was water below your excavation, above your excavation level, then there's a risk of that coming into the site. So you will only specify contiguous where you know the water level is down below your maximum dig level. King post walls, that's another sort of area where the restricted access piling can come into play. Again, this is just a product, but it's a combination of different components, and it could be an augured pile, it could be a driven pile, which is installed with a restricted access rig. So these are just a series of pile positions, whether that's a CFA, SFA type pile or a driven H section, and then infill concrete or timber panels. They're more commonly used in Europe. Occasionally you do see some hybrid systems where there is infill pairs of sheet piles introduced in between steel H sections. So lots of different things that can be done in terms of installation methods with essentially the restricted access, the mini piling equipment. So as you can see from that list that we've got on table slide 11, these are all things that potentially might be suitable for your project, but in consultation with your chosen piling contractor. These are the things that need to be identified, which are appropriate, which fit the cost profile for the scheme, which tick the box for the performance that you need to be provided by the piling. So moving on to slide 12, this is some examples of where mini piling could benefit your project. So if you wanted to extend outwards in areas, extension to an existing building, something like that. That's where you might want to use a mini piling rig where you may not necessarily be able to get a full-size rig in there. Where you've got unfavourable ground conditions, we see it time and time again. People start doing self-build projects, don't really have much understanding of the ground conditions. They start digging down for the footings for the build, and then they find that they're going down to significant depths, such as where piling will become cost effective rather than mass fill concrete footings. So again, the lesson there is to understand what ground conditions you've got on your site, and understand whether it is a traditional sort of construction method that you're going to deploy, or whether you're likely to need piling. I've had no end of conversations with clients over the years where the piling costs have come as quite a shock to the projects, and quite a number of them have been curtailed because it wasn't factored into the cost for the build. So again, sort of restricted access zones, anywhere we've got a limitation on, let's say, a weight limit on a bridge, access to the site, overhead restrictions, BT cables, power lines, things of that nature, working under a overhang, something like that. If there's a limitation on height of the rig, collapse radius close to network rail, some asset that may be at risk should something go awry. This is where restricted access rigs come into play to be able to deliver the engineering, but in a more appropriate method. So mini piling, widely used where strengthening structures is needed, so an enhancement to an existing structure. Columns are being introduced on remodeling on a building. You're likely to need some piles on the pile cap to take that column load coming down. So these can all be done. The smallest mini piling rigs can operate in 2.2, 2.3 meters headroom, 300 diameter. Sectional flight auger pile, take it down 15, 18 meters, probably a little bit more if you need to, in the right sort of ground conditions. So there's lots of things that can be done. We like to think mini piles are environmentally friendly. They use less concrete, less steel than other piling method systems. Reduce foundations carbon footprint, minimal disturbance, vibration to adjacent structures. So they're all good. So moving on to slide 13. A few images there you can see of different sorts of equipment. Top left-hand corner, Camacho rig, quite a big sort of drilling rig. Good flexibility, dexterity, lots of things that can be done with that rig. On the right, clem rig, geotechnical rig. Again, lots of options for that in terms of physical orientation of the mast, in terms of how it's penetrating into the ground. Doesn't necessarily have to be on the vertical axis. So that's a good start. So on the right-hand side at the top, we've got a clem geotechnical rig, very dexterous rig. Lots of things that can be done with that. Bottom left, got a small clem 702, very good rig. Most piling contractors have got one of these. Very lightweight, remote power pack, so that can be detached and put somewhere else. So the rig can operate in a very small sort of footprint. Has good capacity in terms of cross-sectional area and penetration depth that it can get to. So really good rig. It's got some reasonable output as well in terms of how much you can do per day. So that does redress some of the cost in terms of bottom left, we've got a Clem 702, very good rig, lots of capacity, lots of options in terms of cross-sectional area that can be provided. Got a detachable power pack, so that can sit remotely, and the rig can operate in a very small footprint. Most piling contractors have got these on fleet. Really good dexterous rig, widely used. And the bottom right, we've got another geotechnical rig. Just gives you an idea of the size of the equipment that we would pretty much classify as restricted access mini piling rigs that can deliver the solutions. Moving on to slide 14, we're just going to go through a few case studies, things that we've done. So the picture you see there is the Clem 702 that we've just talked about. So on this particular project, we had 563 micropiles. Also had some precast piles. So we used Yuntans and Banuts for the precast piles. The actual site itself is down near Richborough. It was to install engineered pile solutions for 60 pylons and 2 temporary bridges. Quite a difficult project to deliver, just the physical constraints being quite remote, logistical operations in terms of getting materials to the point of use for the rigs. Quite a long project for us, 11 months. And we used the Clem 702 for the mini piles due to overhead cables. Obviously, a restriction from the provider in terms of maximum height and arcing radius on the cables. Moving on to slide 15 now. So residential development in Beeston. Residential developments were bread and butter really for the restricted access market. Generally, it's just an enhancement to an existing building or plot, so limited number of piles, not necessarily enough to deploy a full-size piling rig, nor would you necessarily want to do the enabling works to get a full-size piling rig on there. This particular scheme, we did 16 300 diameter SFA piles, sectional flight auger piles, 14-ton restricted access rig. So it's a vibration-free technique, so there's no issue with adjacent homeowners or buildings, businesses. No problems there. Moving on to slide 16, North Road, Durham. Very interesting project for us, multidiscipline. That's what we like here at Aarsleff. So 22 ground anchors. Again, we've sort of talked about those earlier. Quite expensive. You wouldn't specify them unless you really needed them. These particular ones were 15 metres in length. It's quite a large scope of sheet piles. Those range from 5 to 12 metres in length to form a retaining wall, obviously varying heights, which then sort of manifested themselves in different sheet pile lengths. 238 CFA piles, that's the sectional flight auger pile, so this would have been with a full-size rig. Different sizes, 300 diameter and 450 diameter, different capacities, maximum pile length 22 metres, so a good way down in the ground to get the load that we needed. This was to convert a redundant hospital for Durham, come off Durham Council's inventory into some student flats and accommodation. We were there 3 months doing multiple disciplines on the site. The ground anchors were used to anchor back some of the sheet piles in particular areas to restrict the movement of the wall, such that there was no distress caused to the existing building, which was to be retained and utilised in the project. On to slide 17, Frigwood, Eland Valley Aqueduct. Really good job for us. You may wonder why we put this in, but it could become apparent in a moment or two. So this was the largest infrastructure project to date, and this particular piece of works was essentially temporary works. In the middle of the Welsh Valleys, access very, very remote, and this particular scope was to allow a very large diameter rotary piling rig to get up into the area to form a shaft for the new works. What we've got here is a significant amount of soil nails. So again, what we've learned earlier was top-down construction. So we've gone in, introduced the nails, and then gradually, incrementally reduced the ground level down to reduce the angle to allow this big rotary rig to come in. Very big package for us, quite a significant cost, 670 piles were installed. We utilised the Clem 806 drilling rig. It's essentially one of the images that we've looked at earlier as the sort of mini piling rigs, restricted rigs. Nice piece of work, and well delivered by the guys. We were 3 months on site, and yeah, very favourable. Moving on to slide 18, Shymore Development. So this is drilling and grouting. What you'll see from the photograph, hopefully those guys that know anything about piling, is there's no piling mat down there. So the geotechnical side of things, they don't need a piling mat, and very rarely do we get given one. So again, if we're using the water-based flush, then it's going to get awfully muddy, messy, and you need some Wellington boots. On this particular project, we had 503 holes, 2,700 tonne of grout was batched on site and then pumped into the various voids. We also capped a mine shaft and treated a site area of just over 5,600 square metres. 3 rigs on site. Nice job, but messy. Slide 19. Little job in Durham. This is actually a soil nailing job, but on the images on the right-hand side, you get an idea of the restrictions and the difficulties of installation on just a steep slope. So what we've got on the top left-hand side is guys working from a basket, man-riding basket with a long reach drill system to introduce the nails. Bottom left gives you an idea of more of the challenges that we faced on this particular job with the watercourse at the bottom. So again, sort of air flush would have been preferable here. Water flush would not have been ideal and caused quite a potential problem should it reach the watercourse. So the management of this particular job was quite critical that there was no materials entering that watercourse. Not a amount of work, only 92 nails, but very difficult in terms of delivery. Moving on to slide 20. This is a scheme that we delivered down in Dogmansfield for a reinstatement of a canal. Something was being brought back into the infrastructure down there. The scheme involved some sheet piling, but the ground was fairly difficult in terms of being able to get the piles with enough embedment into the ground to stop the potential movement of the wall. So ground anchors were introduced here to anchor the sheet piles back, which obviously allowed the piles to be relatively short because of the fixity at the head. Just gives you an idea of some of the situations where restricted access piling would be installed. All this, the sheets and the anchors were all installed from floating pontoons, so we're actually sitting on the water on temporary working platforms installing all of these works. So quite difficult, quite costly, but there was not much we could do to change any of that. Moving on to slide 21. Shakespeare. It's a nice multidiscipline job for us up in Leeds. Regular client for us. So we did some steel tubular piles, some drilling and grouting, and some soil nailing, all on the same site. Lots of different equipment that was used. Again, you can see the guys there, they're doing the drilling and grouting in the picture. Clem 806, quite a useful piece of kit. No piling mat again, if you noticed. That kind of gives you a bit of a flavour of mini piling, hopefully, what can be done, what we can use, different techniques. Hopefully it's given you some food for thought. Slide 22 here just gives you an indication of all the things that we are signed up for. Members of the FBS, British Drilling Association, ROSPA, all the things that we need to be able to deliver the things that we need to for our clients. We do all the awards on slide 23. We like to think that if we get chosen to be in the finalist lists, that we're winners, essentially. Whether we win or not, just gives you a good feeling that your project's standing out enough to get into the top 10 listing. So we try and we try and we try to enter these things and win and get the recognition for what it is that we do. 24. So I think I'll probably call it a day at that. If you've got any queries, you want to give us a call. Numbers on your screen now. Email address is equally there. What I would say is, if you think you need some piling doing, speak to a reputable contractor. Some members of the Federation of Piling Specialists would be recommended. You can find us at the top of the list. Hopefully it's been insightful. If you've got any questions, please do not hesitate to give us a call or drop us an email. Appreciate your time. Stay safe. Thank you.